So let me recap some of that. On Blackboard, we now have homework solutions right on that side, left sidebar. We've got a new list of homework for Monday, which I will add to, right? 2.3, number 23, using L'Hopital's rule. 2.5, number 41, using a conjugate and dividing by the highest power of x. And 3.1, number 35, that's a tangent line, but use the shortcuts. Once we're in chapter 3, we're only doing shortcuts for derivatives, okay? I'm just putting this on the recording, right? I already said it all to you live. And then there's our schedule for the next few classes here. So we had a request to do an LCD problem, right? So we're going to try and find f prime using a limit, and then we'll do a tangent line. What's the domain here? What's the domain of this function? You remember the good old days of pre-cal? Domain of this function, every x except for 1 over 2, yeah, 1/2, right? 1/2 will make this divide by 0, right? So when I do my tangent line, I can pick any x except for, right? You got it? Any x except for 1/2. I'll pick x is 2, whatever, doesn't matter, okay? Good, so let's do this. What do we know? F prime of x is the limit as h goes to 0 of f of x plus h. F of x plus h, do you notice I just wrote f of x, but with empty parens, right? And what am I putting in the empty parens? X plus h, right? Minus the original function, all divided by h. How are we doing here? Are we okay? And this, of course, is the limit as h goes to 0 of star. And I'm just going to use this placeholder so I don't have to keep writing limit over and over while I do the algebra, right? So, as I'm writing star, I like to try and clean up my parenthesis first, and then rewrap any multi-term numerator or denominator. So notice I distributed that -2, and then I rewrapped multi-terms, right? Abigail, okay? Yep, good. Now I'm going to multiply the numerator and the denominator by the LCD, or maybe a common denominator, which is 1 minus 2x times 1 minus 2x minus 2h. Say again? One more time? Do what again? But if I write it again, it's going to be the same thing. So, but are you okay here? Are you okay with the first one? Okay. Then I distributed the -2, right? And then anything that was multi-term, numerator or denominator, I'm going to wrap in parentheses. Then I notice I only have these two denominators in the inside, in the interior, and the product of them is the LCD, and I use it over itself, so I'm multiplying by 1. Yes? Oh, reminder, music is okay during the test or quiz, but I don't want it on a laptop. Unless you can close the laptop and put it away. Just like I can have my music playing, right, on my phone, put the phone in my pocket, right? So now I'm going to distribute this, and I'm going to take my time here and keep the original in black, just so you could see it. And my distributing in green. Is green, can you see the green okay, or should I switch the color? It's okay? Trying to take my time, trying to be neat, trying to be organized, right? And then the best part, my favorite part of the day, is changing to red and then canceling what I can. Yes? Anybody, was Molly in English class? No? Now I'm rewriting. I'm not thinking at all here. I'm just rewriting what I have. I'm trying to do every time I do a step, I'm trying to do something so simple that I won't make a mistake. Abigail, okay? Wait, where? Yeah, so I distributed it, right? First line you're okay with. But notice that I put the green times the 1. The numerator, see the original in black? And then the green is distributed in. Yeah. I can't red lines, matching two red lines, matching two red lines. Those things you can't. You see the green piece that's left over. 1 minus 2x, that's here. Right? The other piece canceled. See the 1 minus 2x minus 2h, that's here. The other piece canceled. Now I'm going to distribute that negative, right? Do you see it? So I got 1 minus 2x minus 1 plus 2x plus 2h. I distributed the negative there. Right? This negative went to the 1, went to the negative 2x, went to the negative 2h. Now, red pen again, the 1's cancel. The 2x's cancel. What's my little reminder? Every term without a factor of h had better go away or you did something wrong. Because at this moment, I cannot let h go to 0. At this one moment, if I let h go to 0, I get 0 over 0 still. So there's a question of when am I done? When you don't get 0 over 0 anymore. So that now the h's cancel, and I finally have my replacement function of 2 over quantity 1 minus 2x, quantity 1 minus 2x minus 2h. What is this? The slope of the secant line for some x and for some distance later, h. But I don't want the slope of the secant line, I want the slope of the tangent line, so I'm going to let h go to 0. So f prime of x is the limit as h goes to 0 of star, and I'm going to just plug in 0 for my h. So it looks like I get 1 minus 2x, that quantity twice. So that is 2 times 1 minus 2x quantity squared. And there's my derivative. Yeah, but how far back do we have to go? How far? Oh, you're taking pictures. So let me get you the whole first page, okay? We'll do it in 3 photos. Here's the first. Got it. There's the second. There is the third. Nice. So, how do we check this, right? How do we check this? We're going to put in that original function into Desmos. You should be doing this with me. That was 1 divided by 1 minus 2x. Now, it's interesting to see one nice way to check my derivatives is to notice, and put me on a snowmobile, okay? I'm on a snowmobile, right here, riding on this, right? Notice what kind of slopes do I have? Positive or negative? Positive. What about here? What kind of slopes do I have? Positive. So when I graph my derivative, and I'll let Desmos do it, I should notice that the heights of the derivative graph are always going to be positive. So y equals f prime of x. Oh, I know what to do. So notice, right, let me pretend right here that my slope, my original function is in green, right? So right there, that slope is what number? Right here, at that point, what's the slope? 2. That's not height of the derivative. So notice on the green hill, my slopes are all positive. Notice the derivative is always above the x-axis, so it's positive. So that's a first, and that's a chapter 4 concept that we'll talk about when we get to chapter 4. But of course, I would rather hide my function and then compare it to my derivative, right? Which was 2 over 1 minus 2x quantity squared, right? And I'm just trying to make sure that pieces match up. So as I hide the black curve, right, you see it's matching with the blue curve, right? Justin, one more time? Yes. Can you, if you want to find me one, I'll do it, or I can do the one that I did in the earlier class. But one more thing before I leave here, let's do a tangent line. We might as well pick something nice and easy. So I got f of x is 1 over 1 minus 2x. F prime of x is 2 over 1 minus 2x quantity squared. Thank you, Jack. And I'm going to pick x as 1. So what do I need? I need a y value, and I need a slope, right? So y is going to come from f of 1. So that looks like a negative 1. Yeah? You agree? We agree? Yes? And m is going to come from f prime of 1. So that looks like 2. We agree? Why? Abigail, are you actually doing the, put the numbers in and do the calculation? Huh? Positive 2, yeah. Put the number in. 2 times 1 is what? 2 times 1 is what? 2. So I've got a 1 minus 2. That's negative 1. Square it. That's 1. 2 divided by 1 is 2. The tangent line, y minus a negative 1 equals 2 times x minus 1. Right? I'm using the y value here. the x value here and the slope here. So I get y plus 1 equals 2x minus 1. And I get y equals 2x minus 2 for my tangent line. What? Oh, thank you. That's a 2, right? Minus 3, yes? Sorry, thank you. What do I want to do? Yeah, Jack? One more time? Yeah, I won't do that. Because if you look at the secret here is everything is dependent upon just the x. The function of the x is written on the x. So someone will say, here's the y, find me the x, but you know what I mean? But that's not that that's difficult, but it's not never done that way. All right, so I want to plot my point. I had to point, what was it, 1, negative 1? No, what was it? Help me. It was 1, 2, right? Ay. Where's my y value? Oh, I'm showing my derivative. I'm sorry. So 1, negative 1, right? And then tangent line, y equals 2x minus 3. Is that right? Yeah, boom, done. What do you think? Oh, good, thank you. Jack sent me one first. I'll do that one, and then dear, I'll do the one you sent me. Okay? How are we doing? We okay? I can't hear you. Yell it at me. I'm ready. I plugged it into the function to get the height. Right? Okay, this is from Jack. This is another one like we did. So Jack, I'll probably just start it. I just did one like this, so but that's okay. I'm going to find f prime of x. So f of x is 7 over x squared. Of course, that's 7 times x to what power? Huh? Oh, that's a 1? That's x to what power? Negative 2. My shortcut derivative is a power rule. So I get what? Negative 2 times x to the negative 3. So there's my answer shortcut, right? And remember, we're going to be only taking shortcuts from now on. But, right, on this test, I am going to ask you for this limit. So let's start it up, right, using a limit. Let's see if we get the same result. I know f prime of x will equal the limit as h goes to 0 of 1 over x plus h quantity squared minus 1 over x squared, all divided by h. Jack agreed? Yes? So then I guess the only thing we have to kind of think about is what's the LCD? Right? What's the LCD? It's pretty clear that it's x squared times x plus h quantity squared, and I need that over itself. Question? Here? Okay, so I took a shortcut. I like shortcuts. So the function is 1 over x squared. That's x minus 2 minus 4 is 3. And x minus 3 is 1 over x cubed. Right? You agree? Remember, negative exponent means reciprocal. Jack, do I need to keep going? Jack? You okay? What? Mm-hmm. Elizabeth? Good. Nice. This problem's from DR, and this will be our last problem, and then we'll move on to new material here. I want to make this function continuous, right? So find C, no problem, to make f continuous. So I've got this function, a three-piece function. I've got a negative x if x is less than negative 1. I've got minus x squared plus x plus c if x is between negative 1 and 2 inclusively, and 2x minus 3 if x is greater than 2. Good question to ask. So we just have to find that one value of c to get these pieces to all match, right? To connect, right? Is that making sense? So I like to go to Desmos first. Yes? We're ready? Now notice I have two pieces that have to connect at negative 1, and I have another two pieces that have to connect at 2, right? So I'm kind of working on two matching limits here. The two limits that match at negative 1, the two limits that match at 2. I want to put this in Desmos first. So negative x, so y equals negative x for x less than negative 1, right? And the curly brackets, right, for the restriction. Y equals 2x minus 3 for x is bigger than 2. So curly bracket x greater than 2. And in between there, so there's those two pieces. In between, I want a parabola to connect. So that middle piece has got a slider on it, y equals negative x squared plus x plus c. And I'll put the whole thing in first, right? And you can see I want it to connect those two pieces right around there, right? So maybe C is 3 or something like that. Looks like it, right? I can restrict this, right, with the curly bracket, so negative 1. I don't need to use the less than or equal to, but I will, because the computer can't really handle it. It doesn't know, it doesn't show whether those points exist or not. So I'm just trying to make a little bridge, I guess, right? Concept is clear? Yeah? Isker, yes? Abigail, you yell it for me. That's right. We're just trying to connect. Let's not do hypotheticals. Let's just do this problem. Okay. So let's do some work now. How do we do this? Well, which machine should I use if I want to connect at -1? These two. So the limit as x goes to -1 from the left, I'm going to use the function -x. But the limit as x goes to -1 from the right, I'm going to use the other function, -x² plus x plus c. Is there a problem with me? What's the first thing we ever learned about a limit? What do I actually want to try first? Yeah, plug it in. That's all I have to do here. I plug it in. So what do I get on the left? I get the opposite of a -1 equals the opposite of a -1² plus a -1 plus c. So c is 3. Done. Question? Yeah. Yep, I agree. Well, and so what I'll say is, before I go do the other limit, which I don't even need to do, I will set this at 3 and see if it's continuous, and it is, right? I set my c equal to the answer I just got, and I see it connects. Misker, what? Okay. Yep. So what's the key here, right? I got to see where things are trying to connect, and then plug in to find the limits, and then solve for, and this one's easy. I just have to solve for c, and it's done. C is 3. What should I check, though? I should check the limit as x goes to 2 from the left. Which function is that? Good, -x² plus x plus c, right? And I should make sure that equals the limit as x goes to 2 from the right. Which function is that? 2x minus 3, good. And what am I supposed to do to both of those limits? Plug in what? 2 for x. So I get -2² plus 2 plus c equals, what, 4 minus 3. And again, I get c equals 3. It better work out that way. Yes, Jack? Yes. So what are we thinking about? The one, the -1, or the 2? We have to do one at a time, right? Because there's 2 places I have to connect it, right? So at -1, there's the left side, it's that top function. At -1 from the right, it's the middle function. Does that make any sense? Why is it not the bottom? Because I don't care about 1. This bottom function only works when it's bigger than 2. It's only working when the x is bigger than 2. Right? Look at my graph. Right? That's the left-hand function. Right? So when I'm left of -1, I'm using that green function. When I'm right of -1, I'm using the blue function. When I'm left of -2, I'm using the blue function. When I'm right of positive 2, I'm using the red function. Right? Yeah. The right of -1? Yeah, because that's what it says, right? It says use this function when I'm at numbers right of -1. You see? On the right hand side, it says everything between -1 and 2. Now the arrows are getting me left. X is less than 1. That's left. So the two set first machine is on left of -1. Yes, this says as we're going from -1 to but from the left side. Two squared. Yeah, this one? Yeah. What do you plug into X? Do them. Do all the problems. All on my old quizzes, old tests. Okay? All right, here we go. 3.2. Wait. Okay? Yeah, good on that one? Yep, making sense? All right, here we go. New stuff. We're talking about section 3.2, and we're talking about the product and quotient rule. The product rule and the quotient rule. So I'm talking about ways to get derivatives using shortcut methods. And from now on, all our derivatives are going to be done with shortcuts, right? So you've got a list of shortcuts. We're going to be adding to those this week, Monday. We're going to add all our trig derivatives. So we already know if y is sine of x, the derivative is cos of x. If y is cos of x, derivative is negative sine of x. Then we're going to have a tangent function, a cotangent function, a secant, and a cosecant. And then we're going to add all of that to our shortcut list. But this product rule is a way for me to get derivatives of products. So, meaning if I say y equals f of x times g of x, that's a product. I'm going to use the product rule to get y prime. And for the quotient rule, I'll have something like y equals f of x divided by g of x. That's a quotient. So when I want to get y prime, I use the quotient rule there. And for each of them, I have a little loop. I call it a loop because I'm going to get the derivative. It's just a theorem, and I'll prove this theorem to you too as well. So I want to think about the function f and its derivative f prime. I want to think of the function g and its derivative g prime. And then I want to follow my arrows with a plus sign in between to get y prime is f g prime plus g f prime. So notice if I follow that arrow, I get that first f times g prime. There's not, yes? Question? No? Yes. What letter do you see there? letter? Yeah, y equals f times g. Yeah, definitely product, right? Definitely quotient, fraction. What letter do you see there in my loop? It's a letter P, product rule. I went to, Princeton University where Einstein taught in Jersey. I went into their school bookstore and I was going to buy a hat or a shirt, and I said, everything in here has got P on it. Why would I buy this? It's a joke. My quotient rule works out the same way. I want to think of f prime, g prime, but I'm going to use a q and a negative and divide by g squared. So it turns out my quotient rule for y prime is g f prime minus f g prime all over g squared. Hopefully by chapter 4 we won't need this loop anymore, but for now I think you'll stay organized if you use the loop. So if you already know the product rule and quotient rule, if you've got your own method, that's fine. You don't have to use my method. But if you've never done it before, I'm saying, hey, try this one out. It's going to help you stay organized and loop, right? Yeah. So looking at my two loops, the P and the Q, right? Get the function, the first function in the product, get the derivative. Get the second function in the product, get the derivative. Same thing here, but you attach them, you connect them differently. Let me show you a couple of examples that will help. A g squared, yeah. Square that downstairs function. I will prove the product rule to you. My computer science major should prove the quotient rule the same way, okay? Bio majors, no. Cyber, right? No. Chem, no. Computer science, math, electrical engineers probably should do the other proof, okay? Aerospace, proof. I will prove the product rule, right? It's up to you to prove the quotient rule. The same way. Jack, what? G squared. All right, here we go. Example with and without. So we're only doing the product rule today. Friday we'll do quotient rule, okay? So if y equals x squared, is that a product? Is that a product? Yeah. What is it a product of? X and x? Sure. So, but let's do it without first. What's our derivative? 2x, done. Easy, right? Yes? Everyone agree? Good. Now, as the product, what's my first function? X. What's the derivative of x? Good. What's my second function in the product? X. What's the derivative of x? I want to use my product loop with a plus, and I get y prime is 1 times x plus 1 times x, which is how many x's? Done. Same answer. Product rule. So all I'm showing you is I'm going to get some function where I don't need the product rule, but I'm going to show you the product rule works for it. Okay? But what's going to happen is we're going to have some function that you have to use the product rule. So of course we're going to be building a knowledge base of getting derivatives. And first case, take a shortcut whenever you can. If you can't take a shortcut, if it's a product, use a product rule. Right? That's what we know so far. Let's do another one with and without, okay? We ready? So we'll say y equals x square roots of x. What is that? X to what power? X to the 3/2, yeah? We agree? You want to see that in more detail? So I have x to the 1 times x to the 1/2. That's x to the 1 plus 1/2. That's x to the 2/2 plus 1/2. That's x to the 3/2. Right? When you multiply like bases, you add exponents, right? Good. Without. What's y prime? 3/2 times x to the 3/2 minus 1. That's 3/2 times x to the 3/2 minus 2/2, which is 3/2 x to the 1/2, or better yet, 3 square roots of x all over 2. What? You bring down the power, that's the 3/2, and you subtract 1 from the power. 2 over 2 is 1. Yep. We okay? We know how to check this on Desmos, right? Let's check it on Desmos before we do anything else. So I have y equals x square roots of x, right? And then, oh, I want that to be f of x. When I do this, I want this function to be f of x notation so that I can plot y equals f prime of x. And my answer, y equals 3 square roots of x, all divided by 2. And I'm looking to see, I'm going to hide my function, and I'm looking to see the red and the black curve match. Right? If they match perfectly, I know I got my derivative right. Yes? Good. Let's do it with the product rule. So we did it without the product rule just by doing a power rule, but let's do the same problem with the product rule. So what's my first function in the product is x. What's the derivative of x? Good. The second function in my product is square root of x. What's the derivative of square root of x? Hopefully we have this memorized. 1 over 2 square roots of x. You with me? I want to do the loop with the positive product loop. So I get y prime equals x times 1 over 2 square roots of x plus 1 times square root of x. How are we doing? You with me? Do I have more than one fraction here? Yes or no? Do I have more than one fraction? Yes, I have more than one fraction. Our goal is always a single fraction with a completely factored numerator and a completely factored denominator all the rest of the semester. Oftentimes you will be doing your calculus right, but you'll look in the back of the book and the answer will be different. You're not done with the algebra. And the simplest way to think about it is completely factored numerator, completely factored denominator, you should get there. So I need a denominator over here of 2 rad x, so I got to multiply by 1. Yes, you with me? So I know I have 2 over rad x, but what's upstairs? It looks like x plus 2x, right? Rad x times, so no, rad x times rad x is x, right? So what do I have here? I've got 3 x's over 2 square roots of x. And if I just rationalize, I see I get 3x rad x over 2x, right? And there it is, 3 rad x over 2. Done, same derivative. Yeah? Yes, there is practice on WebAssign, and of course, all of the odds in section 3.2 that have products. I mean, you could jump ahead to quotient rule if you want, but I'm going to do that Friday. Let's do one where we have to use the product rule. So these 2 examples I showed you, I don't have to use the product rule. So don't bother. But if you have no choice, then you have to use the product rule. So let's do one where we have to use the product rule. We ready? Hold on. Say again? X rad x. Okay, here we go. So let's say y is sine x times cos x. No shortcuts here. Can't do. I know what the derivative of sine is. I know what the derivative of cosine is, but I don't know what the derivative of the product of sine and cosine is. So I have to use the product rule. So my first function in the product is sine of x. What's the derivative? Cos of x, yes. And my second function in the product is cos of x. What's the derivative? Negative sine of x. I'm using this product with a positive in between for y prime, and I get negative sine squared x plus cos squared x. Just from my pre-cal days, I kind of recognize this derivative. What's the matter? Sine times sine, sine squared. I'm going to rewrite this as cos squared x minus sine squared x, and of course all my pre-cal students recognize this as what identity? Cos of what? I'm worried. Cos of 2x. We should have all those trig identities on our formula sheets. Sine of 2x, cos of 2x, tan of 2x, right? Half angles, double angles, all of the cosine identities you used in pre-cal. Please, on your formula sheet. Let's check this one. So what I had sine x, cos x. Here's the original function in green. The black is my derivative, right? Desmos doing it. I want to put in my answer and see if it matched, right? Y equals cos of 2x. Boom. Look at that. Red and black. Let's do a tangent line there. Let's do a tangent line. Which x value you like here? What x value do you like for our tangent line? Two pi over 3? Okay. X is 2 pi over 3. That sounds familiar, doesn't it? So I've got my function, I've got my x value, I've got my derivative. I need two other things to get before I get my line. I need a y value, and I need a slope. How do I get the y value? Plug it into the original function. So sine of 2 pi over 3 times cos of 2 pi over 3. So sine of 2 pi over 3 is negative, so it would be negative sine of pi over 3. Sorry, sine is positive, but cos is negative. Sine of pi over 3 is minus square root of 3 over 2. Cos of pi over 3 is 1/2. So I have a slope of negative rad 3 over 4. Sorry, a y value. Is that trig bothering anyone? Yep. If you didn't take a trig class, you better start now. You will not make it if you can't do the trig. Khan Academy, trigonometry, about 10 hours of work. You can get it done in one weekend. Sacrifice some social time. Sacrifice a little sleep. So that you don't have to sacrifice a whole semester and repeat the course, right? Make sure you know your trig. Let's plot this point before we move on and make sure it works, right? So what was it, 2 pi over 3? 2 pi is pi. And what did I get? Negative square roots of 3 all over 4. Boom. Ha! I love it. Notice my tangent line. What kind of slope is it going to have? Negative, right? We okay? Anybody? No one's okay? Nathaniel's okay. Chrissy? Petra? Yes? Jeffrey? Anissa? Good. All right, we need a slope. Where do I get my slope from? In the derivative, right? So cos of 2 times 2 pi over 3. So that's cos of 4 pi over 3. Of course, cosine at 4 pi over 3 is negative. Cosine is an x value, right? So it's moving into, so negative cos of pi over 3, or negative 1/2. Hoy, what? From here to here? Cos of 2 pi over 3 is here, and cos is an x value, so that's a negative. So I change my cos of 2 pi over 3 to negative cos of pi over 3. This is how I do my trig. You don't have to do your trig the way I do my trig. You could do your trig the way your teacher taught you, which probably, and I might throw up when I say it, unit circle. Right? Yes? Does that sound familiar? The way you were taught was the unit circle? Yeah, I think it's garbage. So I don't teach it that way, and I don't do it that way. But you do your trig the way you do trig. And if you've never taken trig, get on it. All right, tangent line. Yes, I sound a little angry today, don't I? So y minus the negative rad 3 over 4 equals minus 1/2 times x minus 2 pi over 3. Everybody following me, yes? So y plus rad 3 over 4 equals negative 1/2 x plus pi over 3. Right, I'm distributing there, yes? Negative times a negative is a positive, the 2's cancel. So y equals minus 1/2 x plus pi over 3 minus rad 3 over 4. It looks like I need an LCD of 12. So I get y equals minus 1/2 x plus 4 pi minus 3 rad 3 all over 12. I graph that. Y equals negative 1/2 x plus 4 pi minus 3 rad 3 all over 12. Woohoo! Love it. It's okay. It's okay to walk out of here sometimes and go, I'm a little confused, I'm not sure, but then you got to go revisit, right? You got to think. You got to do problems over, right? It's not everyone's going to get it right away. I didn't. I had to go home or go work in my study group or go to the Math Learning Center and practice and then ask for help. At this point when I was in Calc 1, I was going to be a computer science major. So the math wasn't coming quick for me, believe me. All right, so you don't have to take notes on this. We just walk through the proof of product rule, okay? I don't need you to copy it down. If you were a math major, I'd say, yes, copy it down. Computer science majors, I'm saying, do the process with the quotient rule, improve the quotient rule, okay? So I'm trying to prove, right, that if I start with a product, right, f of x times g of x, I get this loop for my derivative, right? F times g prime plus g times f, right? With me? That's what we're trying to prove. Do you have any idea what we're going to do? Do you know the hell we're about to go through? We're going to take this function and do a difference quotient with it. So I take my function and I go get the derivative using that limit. So what do I put into x to start? X plus h, x plus h. And I subtract off the original function and divide the whole thing by h. Everybody with me? And I don't need you to copy it. I need you to agree or disagree. Agree or go, what? What the hell? So what I do next, don't ignore the red for me, is I add nothing. So here's my original difference function, right, over h, and then I added nothing. This is not me. I'm not a genius. I just am good at remembering things, or at least I used to be. So I'm going to add nothing. Notice I have g of x times f plus h, and then the opposite of that. So this purple is equal to 0, right? Do we agree? The purple is 0. It's not there. But then what I do, and what I often will do if I have a multi-term numerator, is I'll divide and conquer. So I'm going to take these two pieces over h plus these two pieces over h. Right, so here it is. There's my divide and conquer. Right, this one here. Right, you see I have the first two terms over h plus the second two terms over h. Then it begins with an F and ends with a Tom Cruise. Begins with an F, ends with a Sidney Poitier. Begins with an F, ends with an actor. Factor, yeah. So I'm going to factor, and notice what I can factor out of the numerator. It's F of x plus 8. There it is. Do you recognize this piece? Keep going. Right? And I take that limit, that's keep going. And I can factor out a g of x here, and you recognize this piece. That's right. So there's my replacement function. I'm going to let h go to 0. What's left here? If h is 0, what do I have here? F of x. So there it is. F of x times g prime plus g of x is f prime. All right. See you Friday. Get some work done.